Good morning, everyone. Hope all is well. Hope everybody's doing all right. I think everybody's in here. All right. So hope you had a great extended weekend. And we're about to go into another one, right? So let's see. I believe this class left off 1.5. We closed out 1.5 and we're going into 1.6 today. All right. All right. So, see if we can get through 1.6. A few people still coming in. All right, so 1.6 other types of equations. First equation that we have presented before us is 3x to the fourth equal to 27x squared. First thing we would like to do here is set one side equal to 0. So we'll subtract 27x squared from both sides. And that'll give us 3x to the fourth minus 27x squared equal to 0. All right, scrolling up some. So here we have 3x to the fourth minus 27x squared equal to 0. So factor out your greatest common factor, which is 3x squared. So I'll pull 3x squared out of each term. That leaves me with x squared minus 9 in the parentheses. Now that's the difference of squares. So you can break that down into x plus 3x minus 3. All right. Once you factor it completely, you can set each part equal to 0. All right. So we set each part equal to 0, 3x squared equal to 0, x plus 3 equal to 0, x minus 3 equal to 0. I didn't point out that our highest exponent was 4. You just scroll
Lay
up.
down.
So
My bad.
not a problem. So our highest exponent was 4. So we should be looking to get 4 solutions even if we have a repeated value. So that's what happens here. 3x squared equal to 0. Divide both sides by 3. That will give us x squared equal to 0. Then to take the square off of x, you take the square root of both sides. Square root property tells us to do plus or minus. Square root of 0, but of course there's no such thing as a plus or minus 0, so we have 0 being repeated. So, but you only have to write it once, but just to let you know that that would have been 2 solutions there if it wasn't 0. Then subtract 3 from both sides and then add 3 to both sides. And those are our 3 solutions. Mr. Williams, you can just do a thumbs up. Did you get that email? You saw the one I sent to you?
Yeah, actually,
Okay.
that's perfect if
Okay.
that works for you still.
Okay. Yeah. That's fine. I'll send you a
And
link.
actually, I'm not even as lost as I thought I was going to be today.
I
So,
didn't think you. I didn't think. Yeah. We'll talk. We'll talk. All right. Everybody okay? Can I scroll up some? All right, so x cubed plus x squared equal to 4x plus 4. Once again, we're looking to set one side equal to 0. So I subtracted 4x and subtracted 4 from both sides. So it's x cubed plus x squared minus 4x minus 4 equal to 0. Done with that first one. All right, so now we have 4 terms here. So whenever you have 4 more terms, you want to factor by grouping. So group together the first 2, group together the second 2. So x cubed plus x squared is my first grouping. Notice in my second grouping that minus sign that's attached to 4x is also included inside of your parentheses. So don't leave it outside. That has to stay attached to that 4x, or you will be changing the value of the equation. So I factor out my GCF out of each set of parentheses, or pulled x squared out of the first one, leave me with x plus 1, pulled negative 4 out of the second one, leave me with x plus 1. Now that I have x plus 4 in common with both quantities, I can pull that to the outside, and I'm left with x squared minus 4. So that's what I have right here. And x squared minus 4 is the difference of squares, just like x squared minus 9. This time, x squared minus 4 will break up into x plus 2, x minus 2. Then set each part equal to 0 and solve.
Excuse me, I have a question.
Mm-hmm.
I don't understand why there's 3 solutions. I thought there was only supposed to be 2.
My highest exponent, see that my ratio. Our highest exponent was 3. So that lets you know how many solutions you should get if you don't have a repeated value. So since that's why we got 3 solutions. The last one, our highest exponent was 4. So we actually had 4 solutions, but one of them was a repeated value. So that highest exponent on your variable will let you know, will give you an idea of how many solutions you would come around to getting.
Okay, thank you.
Yep,
What does a repeated variable mean?
Repeated.
A repeated solution.
If you go back to the last one we had, this one right here, notice how it was repeated. It was plus or minus 0, but there's no such thing as a plus or minus 0. So that would just been 0 twice.
All right.
So something like that. Yeah. Or if I had factored out, let's say one of my factorizations ended up being x plus 2 and x plus 2, then I would have had negative 2 as a solution twice. So that can occur.
So can you scroll up so I can get a picture of that problem?
Yeah, the original.
No, just this one.
Oh, okay.
Yeah.
Well, hold on. How far? Just let me know where to stop, because that's where it starts.
Okay, yeah. Give me a second. Okay. Thank you.
All right, not a problem. Anybody else before we go to the next one? All right, we done with this one. All right,
1.6 right now.
say again now.
We're doing 1.6 right now.
Yes, that was 1.6 and this is still 1.6. Yep.
Can you go back real quick? I was just about done.
See,
Yeah, I thought
now,
we was gonna go back over 1.5 because I don't know if I was the only one, but that homework had me scratching my head for over an hour.
okay, what we'll do is tally up your questions. I'm gonna set aside a day in which all you can ask whatever questions you want. So we can do it like that. And just address all questions. So we either do it next class or after 1/7. So let me schedule it out and we'll set aside a day and we'll just answer questions. Especially since, you know, we already started the lecture and everything. So yeah, so we'll do it that way. All right. Are we good? Okay. All right. So let's go to this one. So now radical equations have a few steps. Just want to make sure that it's worded out so we can follow them accordingly. So solving radical equations, if necessary, we want to isolate one radical to one side of the equation. Step 2, we're going to raise both sides of the equation to the power of the index of the radical. And we'll see what that means in a second, put numbers on it. Step 3, solve the equation if, solve the equation, then if a radical still exists, then we're going to repeat steps 1 and 2. Scroll up a little. Step 4 is check your solutions, and this is a must because when you're dealing with these radicals, whenever you have an even power or even root, you can do everything correct and still come down with one of them not working. And you'll see what I mean in a second. All right, scrolling up. Okay, so let's try this out step by step. We have the square root of 2x minus 1 plus 2 equal to x. So first thing we do is isolate the radical. So we add, subtract 2 from both sides. That gives us the square root of 2x minus 1 equal to x minus 2. All right, next step, we need to get the square root off of this 2x minus 1 so we can have access to x. Everybody done with the steps? All right. All right, so we square both sides to get the square root off. That square root will cancel on the left, leaving you with 2x minus 1. Then on the right, we have x minus 2 squared, which we will expand out in a second. Very good. All right, so left side is just 2x minus 1, but the right side, x minus 2 squared. So that's x minus 2 times x minus 2. So you fold that out. So when you expand it out, that will give you x minus 2 minus 4, x plus 4. So I did that multiplication out right here. All right, so let me erase this. I'll put it back in a second, but so this is where we should be at. 2x minus 1 equal to x squared minus 4x plus 4 after you multiply x minus 2 times x minus 2. So now you want to set one side equal to 0. So I will subtract 2x from both sides and add 1 to both sides. And that'll give me x squared minus 6x plus 1 plus 5, excuse me. X squared, make sure I say it right. X squared minus 6x plus 5 equal to 0. Yeah. And so once you're here, use your quadratic formula or factor. I went ahead and factored. That gave me x minus 5 and x minus 1. So set each one equals 0, x is equal to 5 and x is equal to 1. Make sure we are okay before we go any further. All right. So remember I said that when we're doing this process, after you have your solutions, you do have to go back and check. So plugging in those two values into your original equation. I don't know how far I can scroll up. So of course, if I scroll up too far, let me know. So we're going to take the 5, plug it into the equation, wherever you saw x, and same thing with 1. Am I still using blue? Am I still on blue? All right, so on the left side, I did 5. So once again, you plug in 5 where you see x. So that's 2 times 5 minus 1 under the radical, plus 2, and then just a 5 on the right side of your equation. 2 times 5 is 10, 10 minus 1 is 9. Square root of 9 is 3. 3 plus 2 is 5, so that checks out. And then on the right side, I plugged in 1. 2 times 1, 2 minus 1 is 1. Square root of 1 is 1. So it's 1 plus 2 on the left side, which is 3. And then on the right side, I had 1. So you see that didn't work. So x equal to 5 is your only solution.
Can you scroll back up a little bit?
All right, how much is a little bit? Is that good? I didn't hear you. Broke
That's
up.
good.
Okay. Let me know when you finish.
Could you scroll just a little bit so I can see the very bottom of the problem?
All right, let me see.
Other way. Oh, wait.
All right, can we scroll up? Somebody was up here at the blue.
Yeah, you can stroll.
Okay, cool. All right, so we're gonna do it again. This time we have more than one radical involved. And so then we'll have to repeat the process. Remember, step 3 was saying that if a radical is still involved, then repeat steps 1 and 2. So this is going to put us in that type of position. So we have the square root of 3x plus 1 minus the square root of x plus 4 equal to 1. So we need to isolate one of our radicals. Since I have a minus sign sitting in front of that second radical, I went ahead and added that one to both sides. And that puts me here at the square root of 3x plus 1 equal to the square root of x plus 4 plus 1. Anybody still holding on to the purple? Okay, I can magnify this a little bit. All right, so once again, square root of x plus 3, square root of 3x plus 1. I messed that all up. Square root of 3x plus 1 equal to the square root of x plus 4 plus 1. So we need to get rid of this radical right here. So we're going to square both sides. So that's what we did here for step 2. Square and square root will cancel. On that left side, leave you with just 3x plus 1. Now on the right side, we have to be careful because now we have to expand that. We have the square root of x plus 4 plus 1 squared. So just like we had, I think it was x plus 2 squared, and we have to expand that out. We have to do the same thing here. Yeah, not a problem at all. Not a problem, not a problem. All right. Scrolling up a little. So now we're going to have the square root of x plus 1, square root of x plus 4 plus 1 times the square root of x plus 4 plus 1. So we're going to pull that out. And let me erase this. So this is the result. So don't forget, whenever you multiply in radicals, like over here, I have the square root of 3 times the square root of 5. You multiply what's under the radicals. That gives me the square root of 15. So the same thing happens here. Square root of x plus 4 times the square root of x plus 4 is the square root of x plus 4 squared. You know, x plus 4 times x plus 4 is just x plus 4 squared. I ran out of room. I'll do it like this. I'm going to do something anyway. Why's my stuff not coming back? Oh no. Sorry,
The
y'all.
computer is as confused as we are.
Yeah, my stuff is acting up. All right, let's see. There we go. I think I'm good now. Okay. So we have when you FOIL it out, that's x, the square root of x plus 4 times the square root of x plus 4, which gives us, once again, this right here, square root of x plus 4 squared. Then the square root of x plus 4 times 1 is just the square root of x plus 4. Then 1 times the square root of x plus 4, once again, square root of x plus 4. 1 times 1 is just 1 in the back. So, yeah. Just got to get used to it. That's all. Just got to get used to it. So in that first term, this one right here, square root of x plus 4 squared, the square root and that square will cancel and leave you with just x plus 4. And then here we can add these together. And that'll give us 2 square root of x plus 4. And we just have the 1 in the back. And then to simplify it as much as possible, we can add the 4 and the 1 together to give us 5.
Okay, so I think I missed it. The when you cancel out the square root and the square,
Mhm.
that gives you the 1 coefficient. Is that right? Is it a coefficient in front of the square root of the other equations?
No. Well, okay, let's go back. So now this is a result of these two being multiplied to each other.
There's always an assumed 1
Yep.
in front of it, right?
Exactly, right. So now this is a result of this times this. You know, square root of x plus 4 times 1. And then the same thing happens here when we're looking at 1 times the square root of x plus 4. That gives
So
you,
where's the red 1 coming from?
that's the assumed 1. They assume you know there's a 1 in front of all of these. If I have x plus 4, square root of x plus 4, they assume you know there's a 1 sitting in front of it. So
Why
that
would
when
they
you,
assume that?
that's assumed, just like with x.
Okay.
They hate
Just like with
us.
x, they assume you know there's a 1 sitting in front of x. Just like with y, they assume you know there's a 1 sitting in front of y. That's automatically, they assume you know that. That's
Okay, wait,
just,
I get it. That's why there's a 2, because you're adding both of them together
Exactly.
now. Okay, I get it.
Yeah.
All right. My brain is tired.
Oh no, it's all good. It's all good. I'd rather you ask versus not asking. He said, why would they assume that? That's a good one. So anything else before we go to the next step? So we need to isolate this, excuse me, isolate the radical again. We have another radical, or still existing in our problem. So we need to isolate that. So I will subtract 5 and subtract x from both sides. And that'll be 2x minus 4 equal to 2 square root of x plus 4. All right, everybody good? So now at this point, you could divide by 2 to reduce, but what I'm going to do is square both sides first, just to emphasize something in the process that you may come across. And that's this part over here. Whenever you square a radical and then it has a number sitting out front, you have to square both parts. That 2 and that radical has to be squared. So the 2 squared is going to give me 4. And then when you square the radical, that cancels out and just gives you x plus 4. So I just want to emphasize that part of the process that you may or may not see, but if you see it, then you know what to do. If you have a number sitting in front of your radical, you have to square that too, or apply the power to that number too. And then here, 2x minus 4 squared is just your regular binomial distribution. The result will be 4x squared minus 16x plus 16. All right, scrolling up. So let me erase this just to see. So that's what we have now, 4x squared minus 16x plus 16 equal to 4x plus 16. That's what we have now. And as always, once we're in this position with our quadratic equation, we set one side equal to 0. So I'm going to minus 4x and minus 16 from both sides. All right, 4x squared minus 20x equal to 0. Factor out 4x. Set each part equal to 0. Those are our two solutions. Don't forget, we have to check to make sure. But all right. Now scroll up, scrolling up. So we need to check both of them just to be sure. Once again, this happens when you have an even power that you have to raise to both sides. One of your solutions more than likely will not work because of the changing of the problem, manipulating the problem in that way. So write it down with the solutions originally. Let's scroll all the way up. All right, there you go. So plugging in 0. Notice we get -1 equal to 1. We're plugging in 5, we get 1 equal to 1. So 0 doesn't work, but 5 does. All right, questions, any questions? I'll scroll up. All right. So this is something that will look better when you put numbers on it, but just going to generally explain it first. So looking at radical equations in the form of x to the m over n, power equal to k. So we're looking at our variable being a fraction and how we would solve that. So first one says if m is even, and m is the numerator of our exponent. We're gonna notice how we will solve is by applying the power of the reciprocal of that fraction. So we had m over n, apply n over m to both sides. So that'll cancel out. And we have to give an account for plus or minus if m is even. And you'll see why when we put numbers on it. And that will give us two solutions. But if m is odd, do the same process. We only get one solution though. So we'll do at least one of each so you can see the difference.
Hmm. Whenever I look down to write this, sorry. Whenever I look down to write that whole form thing down, I'm mixing up my K's and my M's.
Mm-hmm.
Not K's and my N's, my M's and my N's.
Mm-hmm. Was that would you just let me know? Like, did
Oh
you?
yeah. Like I'm pretty sure that when I'm writing down this KM stuff, I'm gonna get it wrong.
Well, when you put numbers on it though, it'll be a little more clear, I believe. So let's put some numbers on it and we see how the process actually is executed. Might be a little better to you. All right, still copying. All right, so before we solve with that, I do want to make sure we understand the process of using these exponents when they're when they're fractions. So if I have 8 to the 2/3 power, always hold true to the fact that the numerator is your power, your denominator is your root or your radical. So it doesn't matter which order you execute it, as long as you hold true to the numerator being your power, denominator being your root, you'll be okay. So if I have 8 to the 2/3 power, I can take the cube root of 8 first and then square it, or I can square 8 first and then take the cube root of it. It doesn't matter as long as you're doing the cube root and the second power. So if you take the cube root of 8 will be 2, 2 squared is 4. Or if you square 8, that's 64, then the cube root of 64 is going to be 4. So it doesn't matter, once again, what order you do it in, just have to make sure you hold true to the right principles. Your denominator will always be the radical or the root. The numerator will always be the power. All right. So when we go about solving this, make sure you keep that in mind. So the first one like this, we have 3.
Wait,
What's up?
I just got to get the last part of the. It's just the same thing without the plus minus, right?
Which part? Oh, you're up there. Okay, yeah.
Yeah. Okay.
That part?
Got it.
Okay, cool. I think you started talking about something else. I'm like, I don't know what I do. Okay. All right. So 3x to the 3/4 power minus 81 equal to 0. So our numerator of our exponent is odd. So that means we're only gonna have one solution. We don't have to worry about the plus or minus. All right. So first thing we would do is isolate. We look to isolate the variable because the exponent of 3/4 is only applied to the variable. So we want to isolate that variable. So we can add 81 to both sides. And we still hold on to purple. Good. Then we divide both sides by 3 because we would have 3 to the 3x to the 3/4 equal to 81. So we divide both sides by 3. And now we are here. X to the 3/4 equal to 27. So now we're in position to execute removing the 3/4 off of X. Remember, that's a power, so we need to raise both sides to the reciprocal of 3/4. So we're going to raise both sides to the power of 4/3. So the reason why that occurs is because right here, 3/4 times 4/3 cancels out to give you 1. And that's what we need, X to the first power. Then over here, now we have 27 raised to the 4/3 power. And then from there, we make sure, once again, that your denominator is your radical, numerator is your power. So took the cube root of 27, which is 3 to the 4th power, 81. And that would be your answer.
I had a question.
Mhm.
Since we have it equal to 0, why couldn't we just plug it into that factor thing?
We had, oh, you talking about right here?
3x. Yes.
Well, you have to factor it. So from then you have to deal with factoring, with 3/4 as your exponent. So that's your problem there. Now, if it was just x to the 3rd power, then there you could do something with that. But
Oh,
because
it doesn't
you
have an A or B to plug in, really.
Mhm. Yeah, there's not much you can work with other than going this route. All right. Now scroll up. All right, so we're going to do this again, but this time our numerator for our exponent is even. Let me erase this. So this is your original equation right here. X to the 2/3 power minus 3/4 equal to negative 1/2. So you want to isolate the variable once again. So we're going to add 3/4 to both sides. 3/4 will cancel on the left. Then on the right, we have the addition of negative 1/2 and positive 3/4. So don't forget, whenever adding, you need to find your common denominator, add those together accordingly. So that gives us 1/4 as a result. So now we have x to the 2/3 power equal to 1/4. All right. So now we need to raise both sides to the 3/2 or 3/2 power. That's what we did here. So they can cancel out and leave us with just x. And then over here, we have 1/4 raised to that 3/2 as well. Don't worry about this stuff on the right. I just haven't erased it. Somebody asked me that probably a couple of classes ago, something about signs. But so now we have plus or minus square root of 1/4 raised to the third power. Once again, here, denominator is your root, numerator is your power. That means we had to take the square root of both sides. That's why we have that plus or minus. Remember, the square root property says plus or minus is always going to be implemented whenever you take the square root or the even root of both sides. So taking the square root of 1/4 is 1/2. Then cubing 1/2 is 1/8 or 1/8. So our answers will be plus or minus 1/8. All right, questions on that?
What does that green word say that's pointing to the 3?
Yep, power, and then the bottom one says root.
Is that gonna always be the case, whether it's plus or minus?
Is what can always be the case.
The top one is the power and the bottom one is the root?
Yes, that's always the case. Yep, yep. Mhm.
Just want to make sure that I don't highlight something if it's not always true.
Oh, you're fine. You're fine. Even if it wasn't you solving, if you have an exponent as your that is a fraction, that will always be the case. The power is the root, power is the numerator, denominator is your root. All right, can I scroll up? You only have a couple scenarios left out of 1.6. So here we have equations in quadratic form. All right, so what do we mean by quadratic form? So if you can look at your equation and look at your second term and look at your variable and see that that's the same variable being squared in the first term or your leading term, then that's considered an equation in quadratic form. So if we look at what we have here, we have x squared attached to the 8, but our first term is x to the 4th, which is x squared squared. So whenever you have that type of relationship, that's considered an equation in quadratic form. Your second term is something, and then your first term is that something squared. And so you do have the option of trying to solve it with it still being in that form. Or what you can do is what we call u substitution. You take u and let it be the x squared, and then substitute u in for that. And so now we have a simpler equation to deal with. So now we have u squared minus 8u minus 9, which is a regular quadratic equation. Any problems with what we've done up to this point? Make sure we're okay. So, well, once you're in your
Does
quadratic,
need more time to write down. Oh,
say again?
can I just have more time to write that stuff in the purple down?
Absolutely not. So, well, while he's writing that down, and most definitely, sir, is not a problem at all. But once you have your equation in quadratic form, you can go ahead and execute your quadratic methods, whichever way you like the most. I'm going to go ahead and factor that. But if you want to lean on the quadratic formula, you can do that as well. You'll still get the same answers. All right. I think we're good right there. So u squared minus 8u minus 9 will factor down to u minus 9u plus 1. And you can set each part equal to 0.
So this U thing is how you solve the problem. It's not like an option to solve the problem.
Right. Well, you want to get used to this because like when we do it in the next one, we're going to have fractions in our exponent, and this will help you as far as solving in all cases. Now, this one, you could have solved this without using the U substitution. The next one, you're kind of putting yourself in a tough spot if you don't, use the U, and simplify the equation a little while you go ahead and execute your methods. So, but like I said, this one though, you could have kind of got around it if you would have let the fourth be in there, because you can factor it with let it be x to the fourth, and so you would have had x squared minus 9 and x squared plus 1. So you could have factored that way. But in the next one, when we have a fraction, you'll see that it would be easier to use the U substitution.
Can you just
Thank you.
explain the description of the form one more time? I know it was as long as you have the same squared in the first and second, but then the first one has to be squared outside of that.
Well, you have to be able to look at this x to the fourth and see that there's a relationship between that and what you have in that second term. In other words, if this was x to the fifth, I wouldn't be able to do this method. Either I can't solve it or I have to figure out some other way. But it has to be whatever's right here squared in that first term.
Got it. Thank you.
Mhm. All right, are we able to go up? Good, good. All right, so go ahead and solve them for U. Just add a 9 to both sides, subtract 1 from both sides. We have U equal to 9, U equal to -1. But of course, we weren't solving for U. We have to go ahead and put our x squared back in. And that'll be x squared equal to 9, x squared equal to -1.
I knew that was going to happen later on. But I was asking that question. I was like, this sounds like extra steps.
Right. But like I said, I promise you, certain ones, they are complex in such a way that it's not really extra steps. It's just the steps that you have to take. You know what I mean? So, yep. So here, take the square root of both sides in order to get the square off of x. And that's going to be plus or minus 3. And then plus or minus I, because we took the square root of -1. So we have 2 real solutions, 2 imaginary solutions.
Is there any possible way for us to check our answer when it comes to I?
Yeah, plug it in. Yep. Oh, hold on. Yeah, just plug it into these x's. And
All
Yep.
4 answers?
well, you do one at a time. No, you can't do, yeah, you would just do one at a time. So if you want to check 3, you plug 3 in there. If you want to check -3, you plug 3. Each one of them you have to do, it's 4 different solutions. So you have to plug each one of them in individually and check your answer. So, yeah. All right. Can we try the next one?
Now we only need to check our answers if it tells us to check our answers, or because I don't see that we did that there.
Well, normally you have to do, the only time you have to do it was in the ones wherein, where we go. These ones right here, when we were talking about squaring both sides. And we had these radicals. Those are the ones when you have to check it, because even if you do everything right, one of your solutions will not work because of you manipulating the problem. The type of manipulation that we're doing to solve, they call for you to check it. Now, the other ones, checking is an option, because if you do it correctly, then your answer should be correct. So that's why it's not really necessarily a part of a mandatory part of the process with these other ones, because if you do everything right, you will get the right answer. Once again, in those other ones, you do everything right, one of them still won't work.
Okay, thank you. I'm sorry.
Oh, no, you're fine. All right, so let's do it again, but this time we have 5x to the 2/3 plus 11x to the 1/3 plus 2 equal to 0. So this time x to the 1/3 is that piece that's being squared in the front term, or that first term, that leading term.
Now, how many points are we going to lose if on the answer portion we just write no?
No?
I'm just no. I'm like, you see the problem? Oh, no, thank you.
Well, it would be the same amount as if you try to get it wrong, I guess. But yep, so we see the relationship here. We have 1/3 x to the 1/3. That's in that middle term, that second term. And then in the first term, x to the 1/3 squared, because 2/3 is 1/3 times 2. And so we see that relationship. And that means we have that quadratic, that equation in quadratic form. All right. So we'll let u be equal to x to the 1/3. If we were to substitute u in for that, it gives us an easier equation to deal with it, which is 5u squared plus 11u plus 2 equals 0. All right. Once again, once it's in this quadratic form, you can use your quadratic formula or factor. I decided to factor 5u plus 1, u plus 2. Solve for u. And we have these two statements. U is equal to -2, u is equal to -1/5. All right. So remember, we didn't solve for u, or we didn't have u originally in our problem. We needed to solve for x. So we plug in x to the 1/3 for u. Here, just emphasizing that x to the 1/3 is the same thing as cube root of x. So if you want to get that 1/3 power off of x, we need to cube both sides. So that's what I did in the next step, x to the 1/3 cubed, and then -1/5 cubed. Then on the right, x to the 1/3 cubed and -2 cubed. And that will give us the solutions of -1/125 and -8. All right, any problems? Any problems? Got one more scenario and then we'll be done for today. Very good. Absolute value equations. Ended on an easy note. Ended on an easy note. I think y'all will be okay with this one. So we have the absolute value of 2x minus 3 equal to 11. Can I scroll all the way up? Don't know if you're still copying or not. We're done with the red. Okay, if not, let me know. Okay, I'm gonna do it like this. So if we want to take the absolute value, or if we want to solve an equation with the absolute value, one thing we have to hold true to is that if we want to solve the absolute value of u equal to c, then we're going to solve u equal to c and then solve u equal to negative c. So in other words, when I look at the absolute value of 2x minus 3 equal to 11, I need to figure out when 2x minus 3 is equal to positive 11, and I need to figure out when 2x minus 3 is equal to negative 11. I didn't even, because of when you take the absolute value of 11 is 11, take the absolute value of negative 11 is 11. So that's what we're going to do. We take 2x minus 3, set it equal to 11. Then we set 2x minus 3 equal to negative 11. So that's all you would do. Take what you have in your absolute value equal to what you see, which is at positive 11, then set it equal to the negative 11, and then solve for x. All right. So go ahead and add 3 to both sides. Did it again. So that'll give you 2x plus equal to 14, 2x equal to negative 8. Then divide both sides by 2. X is equal to 7, x is equal to negative 4 for your solutions. All right, any problems with that before we do another one?
It makes sense.
Glad I could help out, sir. Glad I could help out. All right, am I okay with scrolling up? So for the next one, 5 times the absolute value of 1 minus 4x minus 15 equal to 0. So notice the first step is that we want to isolate the absolute value. So before we do what we did in the last problem, we want to get the absolute value on one side by itself. So we can add 15 to both sides. Of course, if I scroll up, somebody still copy, let me know. Are we good with the last problem? Okay. So if you add 15 to both sides, divide by 5, absolute value of 1 minus 4x is equal to 3. Now that we're here, we have an absolute value by itself, 1 minus 4x, absolute value of 1 minus 4x equal to 3. We can now set 1 minus 4x equal to 3 and 1 minus 4x equal to negative 3. All right, so from there, you just solve your 2 linear equations. Subtract 1 from both sides in each case. Then divide by negative 4. And we have the 2 solutions of negative 1/2 and positive 1. All right. One last scenario, and then that'll be it. So here we have the absolute value of 3x minus 7 equal to negative 21. So don't forget, whenever you are solving an equation, you're asking yourself, when is this equation true? What value you can plug in for x to make this statement true. In this case, we're saying specifically, when is the absolute value of 3x minus 7 equal to negative 21? And the answer is never, right? Because remember, we talked about absolute value. Whenever you apply the absolute value, the result will always be positive. Absolute value of 11 is 11. Absolute value of negative 11 is also 11. So the absolute value of 3x minus 7 can never be negative 21. So if you isolated your absolute value and the result or the comparison is to a negative number, your answer is going to be no solution, because absolute value of a number can never be negative. So once again, this right here can never be negative 21. All right. But once again, that occurs after you isolated your absolute value. That's where you can make that clean comparison. All right, questions.
So anytime you run across a problem that's written out in this exact form because it's already isolated and you see a negative in front of it, you already know that it's no good.
No solution, right? And then now it is possible they can give you one that you have to isolate the value, absolute value, like we did in the last problem. And then once you get here, do your comparison, and go from there. Yep.
Between you and me,
Mm-hmm.
how difficult would it be to get you to press that share button on the OneNote and send it to my email?
Let me see what's going on here. Anyway, let's talk about that. Let me look at that and see and make sure I'm not violating any type of state laws with sharing stuff. I don't think it's a problem, but let me make sure, because I try to make sure I don't want to, because it's not my computer. It's Norfolk State's computer and TCC's computer. And so let me make sure. I don't have a problem with it. As long as I'm not violating anything, get my computer taken away, then I'll be all right.
Brandon's over there dying laughing.
Look, I don't have money like y'all, man. I got to get these free computers as I can.
Nah, what's
Money
funny
like
is he was
y'all.
trying to
Hold on a
tell me
minute. Money
about
like
being
y'all.
recorded. No, he was trying to talk about being recorded last time, and over here he's trying to like get you commit felonies and stuff.
Right, you see what I'm saying? Like
Talking about some money like y'all. Who got money? Nobody got money.
I think you don't know who caught that one. See, so we can still say no and get a point from the final exam there. Somebody went back to your no question. Yeah, I mean, if you just skip the problem, it's not going to be extra points because you skipped it. So
I'm not asking for anything felonious. I'm just asking to see the notes so I can study in my own time. Like I get the notes from other classes, not classes that I name, but
Right.
Most of the example problems are also, like I said, written out in the textbook with explanations of each step by step.
Yep. So yep, they are in the book as well. But I'll check that share thing because I don't mind sharing the notes because it's just my notes, writing them down. And then like I said, as long as sharing stuff from off of this computer don't violate some kind of state law, then we good to go. So yeah.
Ignorance of the law makes you exempt from it.
Do what now?
Ignorance of the law makes you exempt from it. The less you know, the better.
I don't think that's how it works, sir.
Okay, real quick, I'm going to ask a super basic question that I probably should know, but all right. You know those straight lines that are boxing in part of the equation? What the hell is that called?
Absolute value.
So like the straight lines, that just means absolute value.
So absolute value of 3 is 3. Absolute value of negative 3 is also 3. It just ensures the positive result.
Okay, and then you said ensures the positive result. So the absolute, when it's something's an absolute value, does that make it kind of like exempt from, you have to like solve what's in it first to be able to do, like whenever you have parentheses.
Yeah, parentheses, yeah, if you had the absolute value of 5 plus 2, and then you would be expected to do that first.
Okay.
Yep.
Got it.
All right. Oh, I appreciate it. Somebody said, yep, that's your favorite class. I appreciate it. So next class, I will open up the floor for questions. So if you have them, bring them. And then from there, if we have time, we'll jump into 1-7. If not, we'll do 1-7 next week, whatever. Other than that, you guys have a good one. Be safe. And I will see you next class. All right. Hold up. Next class is Monday. Yeah. So Monday, then 1-7 Wednesday. Whatever happens, y'all get it. You know what we'll do. See you guys next class.
Thank you. Have a good day.
Peace.
Thank you. Take care.
Hey, Professor.
Mm-hmm.
So yeah, 4 o'clock is good for me. If you just want
Okay.
to send me that link. If you aren't good at that time, that's cool too. I'll be around. I'll make myself available.
Okay. I'll shoot you that link.
All right, I appreciate it, man.
All right, not a problem.
I think we might be able to work through this.
Yeah, I think we'll be all
Even
right.
though you tried to throw me a curveball today, but I think we might be able to work through this.
Man, it wouldn't be math if I didn't throw you at least one.
And I was telling my girlfriend last night, I'm like, this is like coming out of the womb and having a child and be expected to do linear equations, because that's how long it's been since I've had to look at stuff like this. And she was
Right.
like, and I guess that does make a little bit of sense.
Yeah.
But that factoring thing threw me for a loop for a minute.
Mm-hmm.
But because it's so many different levels of it.
Yeah.
You know what I mean? And then so I think my problem is like this just logically, like I don't see this and look at it like, oh, that's what I'm supposed to write out. And I think that's where my struggle's coming in.
Mm-hmm.
Because after I get it into the form, I don't seem to have any problem solving the equations.
Yeah.
When I look at the problem, it's like, what are you really asking me to do? And then even when some of them ask me to do certain things, it's like I should know how to write this out.
Yeah.
And I don't. So I think once that makes sense, it's like it just needs to click in some way to where, oh, okay. Because after I get it into form, like even watching you go through today, I was more on par on this class than I have been in any class previously.
Yeah.
Because
sometimes it's the more you sit in it, the more it saturates, the more you start to absorb stuff, you know what I mean?
Absolutely.
Yeah, so you just got to give yourself a chance.
I keep putting a lot of time into this because this is kicking my butt, but it's also because I haven't had to in so long. And it is just that repetitious, you got to keep at it. It's
right.
I'm just hoping maybe like now that I even know what questions to ask, I didn't even know what questions to ask you even last week.
Right.
You know what I mean? So now I at least know what to ask and I at least know what directions maybe you can help me. So I'm looking forward to this afternoon, man. Maybe you can clear some of this stuff up for me and make it not look like hieroglyphics or Mandarin.
Right. All right. Yeah,
Cool.
we're gonna make it happen, man. We're gonna make it happen. All right, guys.
I appreciate it. Shoot me that link and I'll see you this afternoon, bud.
For sure.
Thank
All right,
you,
guys. I gotta hit this next class. Anything else before I go?
Later, guys.
Everybody good? Okay. All right. See you guys next class.